February 1943. In the blazing deserts of Tunisia, German troops captured something extraordinary, a fully operational American M4 Sherman tank. They didn't destroy it. They didn't scrap it. Instead, they shipped it back to Germany. There, deep inside the Kummersdorf proving ground, engineers prepared to test it. What they discovered would shock them and change the way they thought about engineering forever. This is the story of War Daddy 2, the captured Sherman tank that made German engineers admit they had never built reliability like this. The date was February 1943. North Africa was a graveyard of machines. The Allies and Axis forces fought across sand, stone, and heat that broke men and engines alike. During the battle near Sidi Bouzid, a German reconnaissance unit seized an intact M4A1 Sherman from the U.S. 1st Armored Division. The tank still bore its American star beneath hastily painted German crosses. It was a rare prize, a perfect running example of American engineering. To the Germans' amazement, this tank would travel more than 350 kilometers across unforgiving desert without a single mechanical failure. No overheating, no broken gears, no engine trouble. German crews who struggled to keep their own tanks running could hardly believe what they saw. At the port of Sfax, the Sherman was loaded onto a cargo ship bound for Europe. German intelligence wanted it intact. This was no ordinary trophy. It was a puzzle to solve. The journey took it through the Mediterranean, into occupied France, and finally north to Germany. Its destination, the Kummersdorf testing ground, 25 kilometers south of Berlin. Kummersdorf was where the German army tested all new and captured vehicles, the most secret and advanced proving ground in the Reich. Everything from engines and transmissions to rocket technology was studied there. When the Sherman arrived, engineers assigned it a new German serial number and license plate. They began preparing detailed mechanical examinations unlike anything they had done before. At first glance, the Sherman looked simple, even crude, compared to the sleek complexity of German tanks like the Panther or Tiger. But once the testing began, that simplicity revealed brilliance. Every component was designed for practical use, not for show. Every system prioritized reliability over theoretical performance. The engine, a Continental R975 radial, started easily and ran smoothly through a wide range of temperatures. The transmission shifted cleanly through 5 synchronized gears. No double clutching, no grinding, no delicate timing. German engineers quickly realized that almost anyone with basic driving experience could operate it. They were stunned. Their own crews trained for months to master German transmissions that could break if shifted carelessly. The Sherman? It drove almost like a truck. As testing continued, the German engineers began to see the fundamental difference between American and German design philosophies. The Germans built machines for peak performance, but only under perfect conditions. They pushed for precision tolerances and technical perfection. The Americans built machines to work, anywhere, anytime, maintained by ordinary soldiers. Inside the transmission, the engineers found herringbone-cut gears. This design distributed stress across multiple teeth and ran far quieter than the straight-cut gears in German tanks. To the Germans, such gears were difficult to mass-produce. To American industry, they were routine, thanks to decades of experience from the automobile industry. Every bolt, every plate, every cable revealed the same story: mass production, standardization, and rugged practicality. Engineers ran the Sherman through a full series of trials: hill climbs, fuel efficiency tests, endurance runs, obstacle courses. They measured engine heat, fuel consumption, and gear wear. They drove it for hundreds of kilometers, and again, it simply refused to break. After each test, they disassembled components to inspect wear. The results shocked them. Parts that would have shown cracks or distortion on a German tank were perfectly intact. The oil stayed clean, the filters held up, the engine kept its power. In one internal report, engineers wrote that the Sherman's automotive performance was more than satisfactory, an understatement by German standards. They found that the tank could travel more than 2,000 kilometers before needing major maintenance. By contrast, a Panther tank might require repair after just 500. The numbers told a humiliating truth. Germany's advanced tanks, the pride of its engineers, couldn't match the simple, robust American design. The Panther and Tiger were fearsome weapons, but their transmissions often failed after a few dozen hours of combat. Their engines overheated, their final drives shattered, and their maintenance times were catastrophic. A Tiger could spend 3 days in repair for every day in combat. The Sherman, meanwhile, was a workhorse. Its design allowed soldiers to swap out engines or transmissions in the field within hours. And if one tank was lost, American factories could replace it almost instantly. Reliability and quantity had become the Allies' secret weapon. In June 1943, Albert Speer, the Reich's Minister of Armaments, visited Kummersdorf to witness the tests himself. He watched as the Sherman climbed slopes, crossed trenches, and maneuvered smoothly across rough terrain. Then the German tanks took their turn. The Panther matched the Sherman only with great effort. The Ferdinand tank destroyer, heavy and complex, stalled halfway up the hill. In front of generals and industry leaders, it was a public embarrassment. Speer later admitted that the Sherman's cross-country performance was better than many German tanks. He wrote that its motor power, relative to weight, gave it mobility definitely superior to German tanks. For a man responsible for Germany's tank production, that was a devastating confession. Behind the technical findings lay a deeper truth, one about industry itself. The Sherman wasn't superior because it was advanced. It was superior because it was buildable. Ford, Chrysler, and General Motors produced Shermans using the same principles that built cars and trucks for civilians. Parts were interchangeable. Training was simplified. Repairs could be done by mechanics with basic automotive knowledge. In Germany, each tank was practically hand-built. Factories used slightly different designs, meaning parts from one Panther might not fit another. This obsession with precision created logistical chaos. The more perfect the engineering, the more fragile the machine became. The Sherman's good-enough philosophy turned out to be the ultimate advantage. While engineers in Germany tested the captured tank, soldiers in the field were reaching the same conclusion. Reports from the Eastern Front and Italy described the Sherman as remarkably reliable and easy to maintain. Soviet crews who received Shermans through Lend-Lease praised their endurance. British modifications, like the Firefly version with a 17-pounder gun, showed how adaptable the design really was. Even German troops began using captured Shermans whenever possible. Unlike Soviet T-34s, which required modifications, the Shermans worked fine straight out of the box. They just ran. One German regiment kept a dozen captured Shermans in service until the final months of the war, because they could depend on them when their own Panthers broke down. By the end of 1943, the evidence was overwhelming. German reports noted that Panther engines lasted only about 1,000 kilometers before replacement. Sherman diesel engines could exceed 3,000. Sherman transmissions stayed intact. Panther gearboxes often failed in third gear. German mechanics even joked that Panthers needed their own recovery tanks, which, ironically, also broke down. The Panther's specifications looked impressive: thick frontal armor, powerful 75mm gun, advanced optics. But numbers on paper meant nothing when half the fleet sat immobilized by mechanical failure. Meanwhile, American divisions advanced with entire squadrons of working tanks. Reliability had quietly become the deadliest weapon on the battlefield. By mid-1944, as the Allies landed in Normandy, the reliability gap had turned into a strategic disaster for Germany. Panzer divisions were forced to limit movement to prevent mechanical losses. Panthers were shipped to the front by train because their drives couldn't handle long marches. In contrast, Sherman units could drive hundreds of kilometers, fight, and then drive again. When fuel shortages and bombing crippled German industry, the problem only worsened. Replacement parts were scarce. Quality control collapsed. Slave labor and sabotage plagued factories. Engines left with cigarette filters in the oil lines, gearboxes misaligned, bearings unlubricated. The captured Sherman at Kummersdorf became a painful reminder of what the Reich had lost: industrial stability, craftsmanship at scale, and the luxury of reliability. In January 1945, as the Red Army closed in, the German Panzer Commission issued a final report. It listed catastrophic failure rates across every major tank type. Hundreds of defective final drives, countless breakdowns, tanks abandoned by their crews because they simply stopped moving. A general summarized it in one sentence: orderly utilization of tanks is impossible. The captured Sherman, by then still operational, stood as silent proof. It had outlasted the factories that built Germany's most advanced machines. The engineers who had once mocked its simple design now understood that it represented something far greater: the power of mass production and mechanical reliability. After the war, the lessons from Kummersdorf didn't disappear. When West Germany began designing new tanks in the 1950s, engineers studied the American approach closely. The result was the Leopard 1, a tank built with reliability, maintainability, and standardized parts at its core. The echoes of the captured Sherman lived on. For the United States, the Sherman's legacy was even broader. It proved that industrial capacity could win wars. It showed that perfection was not the goal. Dependability was. The tank that many soldiers once criticized for being ordinary turned out to be the most extraordinary of all, because it always worked. The story of the captured Sherman is more than just a tale of machines. It's a story about priorities. German engineers pursued the perfect tank. American engineers built one that worked. In war, as in life, the tool that functions when you need it will always defeat the one that fails at the critical moment. Every kilometer that Sherman drove without breaking down was another reminder. Reliability wins battles. Reliability wins wars. If you enjoyed this story of forgotten engineering and history, don't forget to like the video, subscribe to the channel, and hit the bell icon so you don't miss the next deep dive. Which would you rather command, a powerful but fragile Tiger or a dependable Sherman that never quits? Tell us your thoughts in the comments below. Thanks for watching. And remember, sometimes the greatest weapon isn't firepower or armor, it's reliability.